Welcome everyone. This is ANAS JARADAT, a mining engineering student at the University of Wollongong, and I'm here to present for you the effectiveness of thin spray-on liners as a supporting element. Rock support is the solid baseline to any underground mining operation. Over 90% of rockfall injuries in 26 Australian underground metal mines were caused by rocks weighing less than 1 ton. Therefore, most injuries in underground mines have happened within a few meters of the active phase. Generally, fallouts happen between rock bolts and other support components when the rock is cracked or jointed. Underground hard rock excavations have known two types of supporting systems. The first one is rock mass support, which is an example of it, rock bolts, and the second one is surface support, which is an example of thin spray-on liners. A thin spray-on liner is a chemically based layer with a thickness of 3 to 5 millimeters that is applied to multiple excavations operations, especially in hard rock underground mines, by spraying it on rock surfaces to support rock mass. Thin liners membranes are also composed of polymers or water-based substances that are made by combining water, cement, and sand. A high-quality liner mechanism works by sticking tightly to the surface it is sprayed on and confining with the rib side. As is the case with other reinforcing support systems, a supporting TSL is designed to generate forces in reaction to ground movements, therefore minimizing deformation and displacement by increasing the interlocking of blocks and enhancing the beam. These working mechanisms are obtained by, firstly, conducting various sets of laboratory tests to consider the most appropriate measuring test, such as bending test, double-sided shear strength test, and coated core test. Then applying the selected test as the default testing criteria for measuring the mechanism of a TSL. Thin spray-on liners have many applications in the field by rehabilitating, preventing rock falls up to a certain level, supporting the rock face from fallouts, and reducing the damage of rock burst in case of rock fall happens, without mentioning their application in gas management in coal mines by controlling coal seam gas level in coal mines that may lead to suffocation and underground workers. Thin spray-on liners has significant advantages over shotcrete and other traditional used systems in terms of rock reinforcement, including a short curing time, rapid application, high tensile strength, high adhesion properties that prevent the movement of rocky blocks, faster cycle times, less material handling, the ease of application on the rock face, and a significant ability to penetrate joints. These benefits improve the scope for mechanization and safety enhancements in excavations. There is an ongoing consciousness of the environmental, occupational health, and safety hazards connected with the use of some thin spray-on liners products. Between 5 and 20% of unprotected miners may become sensitized and experience deadly bronchial symptoms as a result of repeated exposures via inhalation or skin contact. Another concern is about thin spray-on liners products is their creep behavior under a certain level of pressure. But the biggest concern is that it is still in the early phases of development, which described as newly born technology. The design used was done by evaluating both laboratory models of unsecured rock displacements and in situ observations of loose rock pieces falling primarily due to the strength of the thin spray-on liners layer and rock adhesion. After providing a summary of the technology and its observed and measured support capabilities, an assessment of the potential for rock support is conducted, as well as the advantages of the system in the mining industry. The used design in this research was efficient because of the wide ranges of available samples to test, the motivated mining companies to conduct research about this technology, the multiple sets of tests that may apply, and various products with different properties that are ready to examine. Although this design may sound complete, but research is needed to determine the standard testing procedures to examine thin spray-on liner products in an accredited method. In conclusion, the effect of using TSL as a supporting element in underground mining is a valuable step towards a safer mining environment, and it is considered as the future of rock supporting. However, in order to achieve that, researchers and developers have to grasp their efforts in bringing this material to the center stage of safety in mining industry. Thank you very much.